Okay, in this lesson we're going to take a look at adding and subtracting polynomials, and we'll do that through looking at a whole bunch of examples. I do think that's the easiest way with this. So let's take a look at the first one. So let's say that you have 3x plus 1, there's a binomial, and you want to add 5x minus 4, another binomial. Well, all you have to do is remove any brackets and then collect like terms. So removing brackets, it's going to become quite important to remove the brackets properly when we do subtracting, but 3x plus 1, and again, if you think about this as algebra tiles, that's just those algebra tiles laid out on the table, and now add and lay these algebra tiles out on the table, and then collect them together, which means find those like terms or find the ones that are the same shape. So 3x and 5x are the same shape, that makes a total of 8x, and positive 1 take away 4 would make a grand total of negative 3. There is an extra step to do with these questions, which is to make sure that your answer is in degree order. And that's really a simplification step that's similar to reducing fractions to the lowest terms fractions. Degree order is just make sure that everything is from the highest degree down to the lowest degree, as we explained in the last lesson. Okay, let's take a look at what happens if they're trinomials. So in this case, I've got 3x squared minus 2x plus 1 as a trinomial, plus 4x squared minus 3x plus 2 as a trinomial. Removing the brackets, in this case, well, you'd have squares and rectangles and little tiny integer chips, and on this side you'd have those same shapes, and removing the brackets is fairly easy. Now I have to combine together the like terms. So there's some x squareds, and this is one way that you can do it, is you can actually make up little squiggles and symbols and things like that, or use different colors to show the like terms, so that 3x squared and 4x squared gives you a total of 7x squareds. Minus 2x's and minus 3x's is minus 5x's, and plus 1 and plus 2 is a grand total of plus 3. And just check that it's in degree order, so degree 2, degree 1, and your constant term last. Okay, another example. And in this one we'll do trinomials and we'll add in some more variables. Okay, so notice that it's addition, so adding things just means put them all out onto the table. There's a whole bunch of different shapes, and I cleared out the brackets. Then I look for my like terms, so there's some x squareds, there's some more x squareds, that would give 9x squareds. Here's some xy's, and here's some xy's. Minus 2 and minus 3 is minus 5 xy's, and plus y squared, take away y squared. Well, no y squareds. And now I look to see if this is in degree order. So degree 2, so the tiebreaker is alphabetical. XX comes before XY, and I'm done. Now let's take a look and see what happens if I do subtraction. So 2x plus 1, but I'll take away 5x plus 3. Well, now clearing out these brackets means something more. The 2x plus 1 is out on the table, but now I want to take away the 5x, and I also want to take away the 3. So what I've done here is I've used the distributive law, and I've distributed this negative sign. So anytime there's a negative sign in front of the brackets, make sure that you distribute it through the brackets so that each term switches signs. So the positive 5x becomes take away 5x, and the positive 3 becomes take away 3. And now just continue with this question as you would before, collecting the like terms, minus 3x, and positive 1 and negative 3 is negative 2. The degree order is good, and we've collected all the like terms, we're done. Let's take a look at this again with trinomials. And so I've got 4x squared plus 2xy minus y squared, take away 3x squared minus xy minus y squared, take away all of that, and I end up clearing out these brackets. So the first one doesn't change, because basically there's a plus sign in front of here. And now all of these change. So the negative applies to this 3x. Then I also take away a negative xy, which is the same as adding xy. And I take away a negative y, which is the same as adding y. This problem with subtracting away all of these terms by changing all the signs, this is the most common mistake students will make when doing these questions. So just be really, really, really careful with them. So next we look for all the common like terms. 4x squared, take away 3x squared is 1x squared, and you never write the 1. An x squared is exactly the same as 1x squared, so you don't write that coefficient of 1. And then we've got some xy's here and some xy's here. That gives a grand total of 3xy's. And then minus y squareds, those are different than these plus y's at the end. And is it in degree order 2, 2, 2, xx, xy, yy? So those are tied, but in the right order because of alphabetical. And then this little term of degree 1 comes at the end. Okay, let's take a look at another example with 3 different trinomials. Actually, let's make them 3 different polynomials and see if we can add and subtract them together. So in this last example, my first polynomial is going to be 5xy squared plus 6xy plus 3y squared minus 2x minus 1 plus the polynomial 5xy squared plus 6x squared minus 3y squared plus 3x plus 5. Take away the polynomial 2xy squared, 3xy plus, minus x minus 10. And clearing out the brackets, it's going to take quite a bit of room to do this, but clearing out the brackets will give me this for my first term, and 5xy squared plus 6x squared minus 3y squared plus 3x plus 5 for my second term. And probably one of the biggest mistakes students will make with these questions is just copying the correct exponents and numbers down. It's a lot of algebra down there. Not that it's a particularly difficult question, but it is pretty tricky to make sure that you're not making any copying mistakes as you go along. The last term is a little bit tricky. I'll just get some extra space here and make sure that I subtract away these terms, and I think I can squish it in here to one line. So minus 2xy squared, and the minus goes to the 3xy, minus minus x is plus x, and minus minus 10 is plus 10. Okay, and now I look for like terms. So here's some xy squareds, here's some xy squareds, and here's some xy squareds. So 5 and 5 is 10, take away 2 is 8, xy squareds. Then I've got some xy's and some xy's. And doesn't look like I have any others, so 6 take away 3 is plus 3xy. So by putting little symbols on or crossing them out as I go, I'll also know which terms I've used. And you notice that I'm starting on the left-hand side and just going across. It's just a strategy so that I don't miss any. So I'll circle these y squareds. There's 3y squareds. There's minus 3y squareds. So that's none. They just cancel each other out. There's some little zigzags under the x's, and here's some more x's, and there's some more x's. So that's minus 2 plus 3, which is plus 1, plus another one is plus 2 x's. Put a box around the constant terms, and there's a 10 at the end. So I get negative 1 and positive 5 is positive 4, and 10 more is positive 14. And I still have these x squareds, and that's it. So I'll put those 6x squareds at the end. And now I'm going to make sure that it's in degree order. So my first term's degree 3, but I've got 2 terms that are degree 2. So I need to put those into the right order. So that's degree 3. This one should come next because it's xx. Then the xy term. and then the x's are degree 1, and then the constant terms come last. So as you can see, this question takes up quite a bit of space to do. I know some students try to skip this step by just trying to work through the original question, but you'll make a lot of mistakes, especially with that last polynomial that's being subtracted. So just be really, really careful and go ahead and rewrite it out again. Using these little symbols and using little colors to indicate the like terms is extremely helpful, especially in detecting if you've actually done all of the different terms. And then just make sure you put your final answer into degree order. I've got just a couple more questions to go. So let's take a look at this question. Oh, that looks a bit strange. It's all in shapes. So some of you are going to love these algebra tiles and be able to work with this fairly easily, and others are going to have a little bit of a harder time with the algebra tiles. You do need to know both ways of doing this. So these are both x squareds. So if you want to translate this to algebra, that's 2x squareds. These are all negative x's, so minus 3x. That's one polynomial, and I'm taking away, there's your subtraction sign, and an x squared, I'm taking away a negative x, and I'm taking away positive 2. Well, those who like algebra tiles will just realize if those were out on the table and I had to take these away, then I'd basically just lose one of these and I'd lose one of these. Those who like algebra would say, okay, well, let's do what we did in those questions before and distribute this negative sign. That becomes a plus x, and there's your minus 2. And 2x squareds there's your 2x squareds. Take away one of those x squareds, you'd be left over with an x squared, which I showed that you would have right here. And negative 3x's plus 1x, well, that gives you negative 2x, and there's your negative 2x's. So the only kind of weird thing is what happened to this positive 2? Well, when you take away positive 2, you end up with negative 2. And a way of showing that with algebra tiles is right now I have 0 integers on this side. So it could look like that. That could be a 0, or maybe even that would be a better 0, because now I have two positives that I can take away. And if you take away this positive and you take away this positive, you end up with two negatives. Done. So you're welcome just to translate the algebra tiles into algebra and then solve this with algebra. You can do some of these questions, many of these questions, without having to translate it to algebra tiles as well. And we'll see that throughout this unit, and into the provincial in grade 10 they actually have questions with algebra tiles on them as well. So we'll get some practice with that.